students, I am Pratika Patil. Welcome back to my YouTube channel Mathematics Infinity Goals. So today's question is from CSIR-NET December 2016. This question is based on concept of linear algebra. So let us see. Which of the following sets of the function from real number to real number is a vector space R question mark. Then S1 is equal to function f such that limit x tends to 3 fx is equal to 0. Second, S2 is equal to g such that limit x tends to 3 g of x is equal to 1. S3 is equal to h such that limit x tends to 3 hx exists. Then we have four options. Option 1 says only S1, option 2 is only S2, option 3 is S1 and S3 but not S2, and option 4 says all the three vector spaces. In our given question, we only have to find the given sets S1, S2 and S3 are vector space or not. To check vector space condition, only we have to check it is subspace or not. For that purpose, we are going to use this theorem, that is, a necessary and sufficient condition for a non-empty set W of a vector space V over F to be subspace of vector space V over F is that for all A belongs to F, F means filled here, and for all F comma G belongs to W, then A into F plus G belongs to W. That means if this condition holds, then we can say our given set is a subspace. Therefore, we are only going to check this condition. So this is our first set. To check this condition, we have to consider two functions, that is, let f comma g belongs to S1. If f belongs to S1, that means f belongs to S1, then this condition holds. Therefore, we are going to consider limit x tends to 3 f of x is equal to 0. Similarly, we assume that g belongs to S1. If g belongs to S1, then we get limit x tends to 3 g of x is equal to 0. Put these values in our given condition, that is, limit x tends to 3 a into fx plus g of x is equal to, by the property of limit we can write this as a into limit x tends to 3 f of x plus limit x tends to 3 g of x. And we know that limit x tends to 3 f of x is equal to 0. Therefore, put here a into 0 plus, and limit x tends to 3 g of x is equal to 0. Therefore, 0. Then we get answer 0 here. That means any function in S1 gives answer 0. Similarly, this function also gives answer 0. Therefore, this total function belongs to S1. That implies a into fx plus g of x belongs to S1. And this condition holds. Therefore, S1 is vector space. Similarly, we consider second set S2. That is, S2 is equal to g such that limit x tends to 3 g of x is equal to 1. To check this condition, let two function from S2. Therefore, let f comma g belongs to S2. Let f belongs to S2, then S2 gives limit x tends to 3 f of x is equal to 1. Similarly, limit x tends to 3 g of x is equal to 1. Now only have to check this condition. Therefore, limit x tends to 3 fx plus g of x is equal to, by the property of limit we can say limit x tends to 3 f of x plus limit x tends to 3 g of x. As we know, limit x tends to 3 f of x is equal to 1. Put this value here, that is 1, plus, and limit x tends to 3 g of x is equal to 1, that is 1. So 1 plus 1 is equal to 2. But 2 does not belongs to S2. Therefore, 2 does not belongs to S2. This property is not going to satisfy. Therefore, S2 is not a vector space. Therefore, from first condition, S1 is a vector space but S2 is not a vector space. Now only we have to check S3 is vector space or not. Therefore, we consider this is a S3 set. We can consider two functions from S3. Therefore, let f comma h belongs to S3. That implies from this condition f belongs to S3, that means this exists. That is, limit x tends to 3, f of x exists. Similarly, this condition is also true. Therefore, limit x tends to 3, h of x exists. Now only check this condition is true or not. Therefore, assume that limit x tends to 3, a fx plus g of x is equal to, by the property of limit, we can say limit x tends to 3, f of x plus limit x tends to 3, h of x. As we can see above, limit x tends to 3, f of x exists. Therefore, this condition is exist. Similarly, limit x tends to 3, h of x is also exist. That is, this condition is exist. That means addition of both condition still exists. That means this condition belongs to S3. Therefore, this is belongs to S3. This belongs to S3. That means S3 is a vector space. Therefore, from above all cases, firstly we check S1 is a vector space. Second, we check S2 is not a vector space. Lastly, we have checked that S3 is a vector space. Now check in options. Option 1 says only S1. Then only S1. S1 is a vector space, but only S1 is not correct. Therefore, option 1 is not true. Now second is option 2, only S2. Then we know that S2 is not a vector space. Therefore, option 2 is not true. In option 3, S1 and S3 are a vector space but not S2. Obviously, this is a true. Therefore, option 3 is true. And last option is all the 3 vector spaces. Obviously not, because S2 is not a vector space. Therefore, option 4 is not true. So, in this question, option number 3 is true. Thank you. Please like,